Let's take a brief review of rational exponents. By rational exponents, what I mean is an exponent, like this b over n, that is a fraction. When we have a fraction for an exponent, we can convert this to radical notation by knowing that it consists of two pieces, a power, which is the numerator of the fraction, and a root. So the index of the radical is in the denominator of the fraction. Note that the n here ends up being the index of the radical in both of these different ways that I can write the expression, and that the numerator m ends up being the exponent in both of these different ways I have of writing the expression. One way we can remember this is to think of a power as a flower. Here we have a flower. On the top we have flower power. And on the bottom we have the root. So powers are like flowers. The root is at the bottom of the fraction. Looking at these two different ways of writing this expression, what we get from this is that it doesn't matter whether we apply the power first and then the root, which is what we see in the first instance. Just thinking about order of operations, this would be power first, then root. Or if we take the root first and then apply the power. As long as our fraction was reduced, it doesn't matter what order you do this in, you should get the same result. And we'll illustrate that with the example 8 to the power 2/3. I can write this as 8 to the power 2 inside of a cube root, or I can write this as 8 inside a cube root, and then the whole thing being raised to the power 2. So let's follow order of operations for both of these ways of writing it. On the first one I would square 8, which gets me the cube root of 64. Then I have to recognize the cube root of 64. 4 to the power 3 gets me 64, and therefore this is equal to 4. In the second example, I would take the cube root of 8 first, which gets me 2. That cube root of 8 is still inside these parentheses that are applied to the second power, and 2 squared gets me 4. So we can see from this example that it doesn't matter what order you do them in, you'll get the same result. But it does matter to some degree what order we do them in if we're trying to get through this whole problem without a calculator. So I'll call particular attention to what number we had to take a cube root of in each case. Doing it by the first method, we had to take a cube root of 64, which is a relatively large number, and doing it the second way, we only had to take a cube root of 8, which is smaller. This difference gets really exaggerated if our powers or if our base numbers are a little bit bigger. 8 and 2 and 3, all of these are just about as small as they can get and still illustrate the idea of a fraction power. If that power is any bigger, this number will grow so fast it'll make it impossible to recognize the root. So we'll look at the next example to illustrate that. What we have here is 16 to the power negative 5/4. The first thing I want to do is use properties of exponents to rewrite it. I don't go straight to radical notation. So a negative exponent is hard to work with as a radical, so I'm going to use the negative exponent rule to rewrite this as 1 over 16 to the positive 5/4, and then rewrite this in radical notation. So if I write this as 1 over, and taking my power of 5 and my root of 4, if I write this as 16 to the 5th, all inside a 4th root, then I can see that 16 to the fifth is going to be a very large number, I'm not going to be able to recognize the fourth root of that. If you're curious what 16 to the fifth is, we can bring a calculator in to help us with that. So 16 to the power 5 looks like 1,048,576. We're not going to get through this problem without a calculator. So let's not do it that way. Let's do it the other way. 1 over, the other way is instead of taking the power first, we take the root first, meaning I write this as the fourth root of 16, and then I raise it to the power 5. Doing it this way makes it very easy. The fourth root of 16 I recognize as 2, because 2 to the power 4 gets me 16. Now all I have to do is raise 2 to the power 5, which is 32, and I'm done. So if we are evaluating a strictly numeric expression, we really want to do the root first. For everything else, it's okay to do the power first. If we're just looking for a simplified form to express an answer in, the other form is fine. And in fact, it looks a little bit simpler because it doesn't have the extra set of parentheses. But for evaluating numeric expressions, root first. Looking at some more complicated expressions, we want to continue to think about properties of exponents. Generally, when working with negative exponents, it's a good idea to move those factors with negative exponents to the other side of the fraction to make the exponent positive before applying properties of exponents. So that x to the negative 5/8 would move up to get us x to the 1/8 times x to the 5/8. And the only factor we have remaining in the denominator now is 1, so we can ignore it. Dividing by 1 doesn't really change anything. I now want to recognize that this is the situation where I add exponents in order to combine these. This is the product rule for exponents. This is a product of two expressions with the same base, and I would combine these by adding the exponents. So 1/8 plus 5/8 is 6/8, which I can reduce then to 3/4. So I will write this as x to the power 3/4. To figure out what form the final answer should be in, I want to look at the original instructions on the problem. Sometimes it will ask for positive exponents, sometimes it will ask for radical notation. If we want radical notation, we would take this an extra step and go ahead and write it with the root of 4 and the power of 3. Since this isn't a numeric expression, and I know I'm not going to be able to simplify it, I'll go ahead and put it in this simpler form with the power first. Looking at this next example, I have these two powers. This is a power to a power situation, and I want to recognize this being the property of exponents that requires us to multiply the exponents. So we have 3/4 times 2/3, and anytime I multiply fractions, I want to cancel out those common factors first. So it looks like in this case I end up with just 1/2, and I would then write this as x to the power 1/2, or if I were looking for radical notation, the power 1/2 is the same thing as the square root of x, noting that that is x to the power 1 with a root index of 2, but of course neither of those has to be written because the power 1 is implied and the index of 2 is also implied. So the power 1/2 is equivalent to just the square root.